Space is vast and mysterious, and some of these strange objects hurtling toward Earth have NASA on high alert.
We discover an asteroid. We have a couple of data points on its position in the sky. You look at its speed, you get a Doppler shift on it. There was some 20% chance it was going to hit Earth on April 13th, 2036.
From massive asteroids to strange, unidentified anomalies, these looming threats are enough to make even top scientists uneasy.
Impact by an asteroid a mile or more in diameter could destroy a billion people, far beyond any other potential natural hazard.
Could any of these objects pose a real danger, or are we witnessing something that can end the world? The answers are as scary as they are fascinating. Join us as we uncover the space objects that have NASA constantly watching the skies. Bennu. Bennu was first noticed on September 11, 1999. It happened during a search for asteroids near Earth that was conducted by a group called the Lincoln Near-Earth Asteroid Research, or LINEA. Back then, it was given the temporary name 1999 RQ-36 and labeled as an asteroid that comes close to Earth. Not long after, Bennu was carefully studied by scientists using radar images at the Arecibo Observatory and the Goldstone Deep Space Network when the asteroid came near Earth on September 23rd of that same year. Bennu later became the focus of a mission called OSIRIS-REx, which aimed to bring pieces of the asteroid back to Earth for study. A spacecraft was sent into space in September 2016, and it reached Bennu 2 years afterward. Once there, the spacecraft created detailed maps of Bennu's surface to find good spots to collect samples. By looking closely at Bennu's orbit, scientists were able to figure out how much the asteroid weighs and how its weight is spread out. Then, in October 2020, OSIRIS-REx touched Bennu's surface briefly to gather some material from it. The sample, placed in a special capsule, was brought back to Earth in September 2023. Scientists are still working on dividing and studying it. On May 15, 2024, a summary of the early findings from studying the returned samples was shared. It was estimated that an asteroid about 500 meters wide, or roughly 1,600 feet, might hit Earth every 130,000 years on average. In 2010, a study led by Andrea Milani and a team predicted that Bennu could have 8 possible chances of colliding with Earth between the years 2169 and 2199. They found that the total chance of such an impact depended on details about Bennu's physical properties, which were not well known at the time. Still, the likelihood of all 8 potential impacts was calculated to stay below 0.071%. The researchers noted that better predictions about Bennu's chances of hitting Earth would need more detailed observations and a model of its shape, along with better data on how the Yarkovsky effect might change its path. In case you were wondering, the Yarkovsky effect occurs when the sun shines on a small asteroid in space, causing one side to warm up. As the asteroid rotates, the warmed side eventually turns away from the sun and cools down. When the heat escapes, it's as if the asteroid gives off tiny pushes in the opposite direction. Over time, these small pushes can gradually change the asteroid's path, similar to how blowing on a balloon can make it move. It's a super tiny effect, but in space, where there's not much else to slow things down, it can make a big difference over millions of years. Later, using radar data collected in 1999, 2005, and 2011, scientists improved their estimate of how the Yarkovsky effect might push Bennu off course. By 2014, the updated probability of an Earth collision during the years 2175 to 2196 was adjusted to 0.037%. This risk corresponded to a score of -1.71 on the Palermo scale. If such an impact ever happened, it was expected to release about 1,200 megatons of energy, measured in TNT. For comparison, the largest nuclear bomb ever tested, the Tsar Bomba, released 54 megatons, while the Tunguska event, one of the most powerful impacts in history, was estimated to release 3 to 5 megatons, with some studies suggesting as much as 20 to 30 megatons. However, Bennu wasn't the only asteroid on NASA's watch radar. Here's another. Apophis. Apophis was first spotted on June 19, 2004 by Roy Tucker, David Tholen, and Fabrizio Bernardi, while they were working at the Kitt Peak National Observatory. Later that year, on December 21st, Apophis came about 9 million miles away from Earth. A few earlier observations from March that same year were identified in December, which helped scientists improve their calculations for its orbit. In January 2013, radar observations from Goldstone confirmed that there was almost no chance of Apophis hitting Earth in 2036, with the odds being less than 1 in a million. By February 2013, the likelihood of an impact in 2036 was lowered even further to a probability of 7 in 1 billion. Scientists reported that in 2036, Apophis would come closer to Earth twice, once in March and again in December, at a distance roughly a third of the way to the Sun, similar to how Venus gets close to Earth every 1 6/10 years. Simulations in 2013 suggested that the Yarkovsky effect could push Apophis through a keyhole in 2029, bringing it closer to Earth in 2051. If it passed another keyhole, it could possibly hit Earth in 2068. However, the odds of the Yarkovsky effect being precise enough for this were estimated at only 2 in 1 million. Later, radar data collected in March 2021 provided more precise measurements of Apophis's path. That same month, scientists at the Jet Propulsion Laboratory announced that Apophis had no chance of colliding with Earth for at least the next 100 years. By 2021, the uncertainty in how close Apophis would get to Earth in 2029 was reduced from hundreds of kilometers to just a few, making future predictions much more accurate. At that time, 6 other asteroids had higher cumulative scores on the Palermo Technical Impact Hazard Scale than Apophis, but none of them had a Torino scale rating above 0. Still, Apophis is expected to remain a potential hazard for thousands of years unless it passes close enough to Venus or Mars to change its path and remove it as a threat. The discovery of Apophis in 2004 was considered surprising because scientists estimated that an asteroid this size, or even larger, coming so close to Earth happens only about once every 800 years. Asteroids of this size are thought to actually collide with Earth only once in roughly 80,000 years. NASA is always keeping track of objects in space that could pass near Earth. For instance, an asteroid called 2024 XU9, which is about 110 feet wide, or roughly the size of an airplane, is expected to come closest to Earth on December 14th, 2024. Right after that, 2024 XB16, a smaller asteroid about 47 feet wide, about the size of a house, will approach Earth on the 15th of December in the same year. On the very same day, another asteroid named 2024 XF4, which is about 200 feet wide and similar in size to an airplane, is also set to pass nearby. The following day, on December 16th, 2024, 2 more asteroids will come close to Earth. The first is 2024 XY5, which is about 71 feet wide, and the second is 2024 XB6, measuring about 56 feet wide, both of which are similar in size to to a house. Earlier that same year, on the 18th of October, a much larger asteroid called 2024 RV50, which is estimated to be about 710 feet wide and comparable in size to a stadium, will also pass near Earth. NASA's Jet Propulsion Laboratory constantly watches these near-Earth objects to calculate the risks of them colliding with our planet. Even though these objects are closely monitored, the chance of a serious impact remains very low because of the vast distances involved. But asteroids aren't the only things to watch out for in space. Interestingly, the next potential threat comes from a source that also helps sustain life on Earth. Let's explore that next. Solar flares. The sun, which is so important for life on Earth, can also cause some serious trouble. It occasionally releases massive bursts of energy called solar flares. These explosions send out strong radiation and charged particles into space. When a powerful solar flare happens, it can disturb Earth's magnetic field and trigger geomagnetic storms. These storms have the potential to cause problems for the technology we rely on every day. For example, radio communications can be disrupted. Solar flares sometimes interfere with radio signals, which can affect things like GPS systems and air traffic control. Satellites can also be damaged by the intense radiation from these flares. If that happens, it could lead to outages in communication and problems with satellite-based services. Even power grids on Earth aren't safe. Solar flares can create strong electric currents that might cause blackouts and large-scale power failures. There is, however, a beautiful side to solar flares. They can create breathtaking auroras, also known as the northern lights, when the sun's charged particles interact with Earth's atmosphere. While Earth's magnetic field does offer some protection, severe solar storms can still have wide-reaching effects. Because of this, forecasting space weather has become more important than ever to reduce the risks posed by solar flares and other space weather events. But the sun isn't the only potential threat in space. Some dangers might come from planets that wander without a solar system. Let's learn about those next. Rogue planets. A rogue planet, sometimes called a free-floating planet or an isolated planetary mass object, is a planet-sized object that isn't tied to any star or brown dwarf by gravity. These planets either start out in a solar system and get kicked out due to gravitational forces, or form all by themselves in space from collapsing gas clouds, much like stars do. The Milky Way might have billions or even trillions of these rogue planets, but no one knows for sure yet. Scientists hope that the Nancy Grace Roman Space Telescope, which is coming soon, will help narrow down these numbers. The first rogue planets were identified in 2000. A team from the United Kingdom, Lucas and Roche, used the UK Infrared Telescope to find some in the Orion Nebula. Around the same time, a Spanish team, Zapatero Osorio and others, found similar objects in the Sigma Orionis cluster using Keck spectroscopy. The discoveries by these teams were later published in 2001, earning both teams recognition for their nearly simultaneous findings. Meanwhile, in 1999, a Japanese team, Oasa and others, spotted similar objects in Chameleon 1, which were confirmed spectroscopically 5 years later by an American team led by Looming. Rogue planets are fascinating not just because of how they form, but also because of the possibility that they might support life. Even though they don't have the warmth of a nearby star, some conditions could make life possible. For example, a thick atmosphere filled with hydrogen might trap enough heat to keep water in liquid form. Additionally, internal heat from radioactive decay or tidal forces from a large moon could provide energy. But life on these planets would face big challenges without sunlight, which is a major source of energy for most known forms of life. Still, scientists believe it's worth exploring these possibilities, and research into rogue planets continues to uncover more about these mysterious wanderers in space. The chances of a rogue planet crashing into Earth are incredibly low because of the huge distances in space and the way objects move around. These planets are very hard to spot, and none have been found that seem likely to hit Earth anytime soon. Still, if something like this ever did happen, the outcome would be disastrous. A collision with a rogue planet, especially one that is very large, would release an unbelievable amount of energy, much more than any natural disaster we've ever known. The crash would likely set off massive earthquakes, huge tsunamis, and violent volcanic eruptions. The destruction would be widespread, and life as we know it could be in serious danger. Debris from the impact would get thrown into the atmosphere, blocking out sunlight and causing temperatures to drop drastically. This would create a situation similar to what is often called a nuclear winter. The effects wouldn't stop there. The force of the impact could even mess with Earth's orbit. This might push the planet out of the habitable zone around the Sun, or worse, send it flying out of the solar system altogether. In either case, Earth would no longer be able to support life. But if you thought rogue planets sound scary, just wait to hear about rogue stars next. Rogue stars. Rogue stars, also called intergalactic or hypervelocity stars, were said to have been discovered in 1997 in the Virgo galaxy cluster. These stars are not held in place in any galaxy by gravity. It was believed they started out inside galaxies before being thrown out due to powerful gravitational interactions, like when galaxies collide or when supermassive black holes come into play. Some well-known rogue stars, such as HIP 85605 and Gliese 710, have been studied for these reasons. Scientists have been investigating how rogue stars form, and a few theories have been suggested. One idea is that these stars get ejected during galactic collisions. When galaxies crash into each other, the gravitational pull can become so intense that some stars are flung into intergalactic space. Another theory points to supermassive black holes found at the centers of galaxies. It has been suggested that in systems with multiple stars, one star might be sent flying at extreme speeds when its companions are pulled into the black hole. There's also the possibility that rogue stars form on their own in interstellar space through the collapse of gas clouds, a process similar to how stars are made within galaxies. If a rogue star were ever to enter our solar system, the results would be devastating. Its massive gravity would disturb the orbits of planets and other objects, potentially causing planets to be flung out of the solar system or even to collide with one another. The intense gravitational pull could trigger huge tidal forces, leading to major earthquakes and volcanic eruptions on Earth. As the star moved closer, it would start pulling in material from the solar system, creating a disk of matter around it. This disk would give off powerful radiation, which could strip away Earth's atmosphere and make the surface uninhabitable. In the end, a collision with a rogue star would completely destroy the solar system, as planets, moons, and other objects would be torn apart and absorbed by the star's gravity. It was said that the chances of a rogue star hitting Earth or even entering our solar system were extremely small. The huge distances between stars in the galaxy were believed to make such events very rare. For instance, the rogue star HIP 85605 was expected to come relatively close to our solar system, passing by at a distance of about 8,000 astronomical units or 0.04 parsecs in roughly 240,000 years. This was described as a near miss when talking about space distances. Similarly, it was predicted that Gliese 710 would pass through the Oort cloud, which is the farthest region of our solar system, in about 1,290,000 years. While this event could disturb the Oort cloud and send many comets toward Earth, the chances of a rogue star actually colliding directly with our planet were thought to be very slim. Still, one other threat that many people probably haven't heard of is called gamma-ray bursts, which we will look into next. Gamma-ray bursts. Gamma-ray bursts, often called GRBs, are considered the most powerful and brightest events of electromagnetic energy known to happen in the universe. These bursts are brief but extremely intense flashes of gamma rays, which are known as the highest energy type of light. GRBs happen in a very short time, lasting anywhere from just a few milliseconds to several minutes. In that tiny moment, they give off more energy than the Sun will produce over its entire lifespan of 10 billion years. The discovery of GRBs goes back to the late 1960s during the Cold War era. At that time, the United States had launched satellites called Vela to ensure countries were following the Nuclear Test Ban Treaty by detecting gamma rays from nuclear explosions. In 1967, these satellites unexpectedly picked up bursts of gamma rays that didn't look like anything related to nuclear explosions. It was later confirmed that these strange signals came from outer space, which led to identifying GRBs as a phenomenon. The first official research paper about GRBs was written and published in 1973 by 3 scientists, Ray Kleber-Sadell, Ian Strong, and Roy Olson, who were working at Los Alamos National Laboratory. GRBs are generally divided into 2 main categories based on their duration. Short-duration GRBs, which last less than 2 seconds, are thought to happen when 2 neutron stars merge or when a neutron star merges with a black hole. On the other hand, long-duration GRBs, which last longer than 2 seconds, are believed to occur when massive stars collapse during a supernova explosion, creating black holes in the process. If a significant amount of gamma rays from a GRB were aimed towards Earth, the results would be devastating. The intense radiation would strip away the ozone layer, which acts as a shield, protecting life on Earth from harmful ultraviolet radiation. Without the ozone layer, the surface of the planet would be exposed to lethal levels of UV radiation, leading to widespread damage to ecosystems and a dramatic increase in skin cancers and other health issues for living organisms. The gamma rays would also ionize the upper atmosphere, creating nitrogen oxides that could cause severe changes in the atmosphere. These changes might lead to a gamma ray burst winter, similar to a nuclear winter, where the climate drastically changes, resulting in global cooling and disruptions in agriculture and the food supply. The intense radiation could also directly damage DNA and other biological molecules, causing mutations and potentially leading to mass extinctions. Now let's discuss the most infamous space event that has been featured in various media over the years as the biggest threat to our existence: black holes. Black holes are among the most fascinating and mysterious objects in the universe. They are regions of space where gravity is so strong that nothing, not even light, can escape. Black holes form when massive stars collapse under their own gravity at the end of their life cycles. The concept of black holes was first proposed by John Michel in 1783 and later by Pierre-Simon Laplace in 1796. However, it wasn't until the 20th century that the idea really gained momentum, thanks to Albert Einstein's theory of general relativity. The first physical evidence of black holes came in 1975 when Cygnus X1, a strong X-ray source, was identified as a black hole. In movies and fiction, black holes are often portrayed as cosmic vacuum cleaners, sucking everything around them with an insatiable appetite. Films like Interstellar and Event Horizon have popularized the idea of black holes as portals to other dimensions or gateways to alternate universes. While these depictions are thrilling, they're not entirely accurate. In reality, black holes don't actively suck objects in. Instead, they exert a gravitational pull, just like any other massive object. If our solar system were to encounter a black hole, the effects would depend on the size and distance of that black hole. If a stellar mass black hole, typically about 10 times the mass of our Sun, were to pass through our solar system, it would cause significant gravitational disturbances. The orbits of the planets would be altered, potentially ejecting them from the solar system or causing them to collide with one another. The intense gravitational forces would generate tidal forces, stretching and compressing objects, leading to massive geological activity on Earth, such as earthquakes and volcanic eruptions. As the black hole draws closer, it would begin to accrete matter from the solar system, forming an accretion disk that emits high-energy radiation. This radiation could strip away Earth's atmosphere and sterilize the planet's surface. In the case of a supermassive black hole, which can be millions to billions of times the mass of the Sun, the consequences would be even more catastrophic. The gravitational pull of a supermassive black hole would be so strong that it could disrupt the entire solar system, potentially tearing it apart. The intense radiation from the accretion disk would make Earth uninhabitable long before the black hole itself reached our planet. But if you think that's bad, wait until you find out that some black holes can also go rogue. Rogue black hole. A rogue black hole, also known as a free-floating, nomad, orphan, or wandering black hole, is an interstellar or intergalactic black hole. These objects lack a host galactic group, typically resulting from collisions between two galaxies or when the merging of two black holes is disrupted. It's estimated that there could be about 12 rogue supermassive black holes on the edge of the Milky Way galaxy. In January 2022, a team of astronomers reported the first clear detection and mass measurement of an isolated stellar black hole using the Hubble Space Telescope, along with the microlensing observations in astrophysics, or MOA, and the optical gravitational lensing experiment, or OGL. This black hole is located 5,000 light-years away, has a mass of 7 times that of the Sun, and moves at about 45 kilometers per second. While there have been other candidates, they've been detected more indirectly. A rogue black hole poses a significant threat to Earth, the solar system, and the Milky Way. If a rogue black hole were to approach our solar system, its immense gravitational pull would disrupt the orbits of planets, possibly ejecting them into interstellar space or causing them to collide with each other. The black hole's gravitational forces would also generate intense tidal forces, stretching and compressing objects, leading to catastrophic geological activity on Earth, such as massive earthquakes and volcanic eruptions. As the black hole draws closer, it would start to accrete matter from the solar system, forming an accretion disk that emits high-energy radiation, which could strip away Earth's atmosphere and sterilize the planet's surface. A collision with a rogue black hole would result in the complete destruction of the solar system, as planets, moons, and other celestial bodies are torn apart and consumed by the black hole's event horizon. The Milky Way itself could be affected if the black hole's trajectory intersects with the galactic core, potentially disrupting the orbits of stars and other black holes, leading to a cascade of gravitational interactions that could alter the structure of the galaxy. But the chances of a rogue black hole colliding with our solar system or Earth are extremely low. The vast distances between objects in space make such encounters highly improbable. For instance, astronomers have identified a potential rogue black hole located about 5,200 light-years away, moving faster than nearly all the visible stars in its area. However, the probability of this or any other rogue black hole getting close enough to our solar system to cause significant disruption is minimal. The vastness of space and the relatively small size of black holes compared to the distances between stars make such collisions exceedingly rare. NASA has also been closely monitoring this next space phenomenon, although it doesn't pose as much of a risk as the others. Comets. A comet is a small, icy body in the solar system that heats up and starts to release gases when it passes close to the Sun, in a process known as outgassing. This produces an extended, gravitationally unbound atmosphere, or coma, surrounding the comet's nucleus, and sometimes a tail of gas and dust blown out from the coma. These phenomena occur due to the effects of solar radiation and the outstreaming solar wind plasma acting upon the nucleus of the comet. Comet nuclei range from a few hundred meters to tens of kilometers across and are made up of loose collections of ice, dust, and small rocky particles. The coma may be up to 15 times the diameter of Earth, while the tail may stretch beyond 1 astronomical unit. If a comet is sufficiently close and bright, it can be seen from Earth without the aid of a telescope and may subtend an arc of up to 30 degrees, which is 60 times the apparent size of the Moon across the sky. Comets have been observed and recorded since ancient times by many cultures and religions. Many comets and asteroids collided with Earth in its early stages. Many scientists believe that comets, bombarding the young Earth about 4 billion years ago, brought vast quantities of water that now fill Earth's oceans, or at least a significant portion of it. Others have cast doubt on this idea. The detection of organic molecules, including polycyclic aromatic hydrocarbons, in significant quantities in comets has led to speculation that comets or meteorites may have brought the precursors of life, or even life itself, to Earth. In 2013, it was suggested that impacts between rocky and icy surfaces, such as comets, had the potential to create the amino acids that make up proteins through shock synthesis. The speed at which the comets entered the atmosphere, combined with the energy generated after initial contact, allowed smaller molecules to condense into the larger macromolecules that served as the foundation for life. In 2015, scientists found significant amounts of molecular oxygen in the outgassing of Comet 67P, suggesting that the molecule may occur more often than had been thought, and thus is less of an indicator of life as had been supposed. It is suspected that comet impacts have, over long time scales, delivered significant quantities of water to Earth's moon, some of which may have survived as lunar ice. Comet and meteoroid impacts are thought to be responsible for the existence of tektites and australites. As of November 2021, there were well over 4,000 known comets. However, this represents only a very small fraction of the total potential comet population, as the reservoir of comet-like bodies in the outer solar system is about 1 trillion. Roughly 1 comet per year is visible to the naked eye, though many of those are faint and unspectacular. Particularly bright examples are called great comets. Comets have been visited by uncrewed probes, such as NASA's Deep Impact, which blasted a crater on Comet Tempel 1 to study its interior, and the European Space Agency's Rosetta, which became the first to land a robotic spacecraft on a comet. Mountain-sized comets have indeed been observed in space, but there have been no comets that have posed a major risk to life on Earth in recorded history. However, the possibility of a future comet posing such a threat cannot be ruled out. Comets travel in more random paths compared to asteroids, making them harder to predict and potentially dangerous. And last but not least, this next event, though known for its glory, might cause a mass extinction event should it happen close enough to Earth. Let's find out more. Supernovae. Supernovae are among the most powerful and luminous events in the universe, marking the explosive death of a star. They occur when a star exhausts its nuclear fuel and undergoes a catastrophic collapse, leading to a massive explosion that can outshine entire galaxies for a brief period. There are 2 main types of supernovae, which are Type 1 and Type 2. Type 1 supernovae occur in binary star systems, where a white dwarf star accretes matter from its companion star until it reaches a critical mass and explodes. Type 2 supernovae happen when a massive star, at least 8 times the mass of the Sun, exhausts its nuclear fuel and its core collapses under gravity, resulting in a violent explosion. The discovery of supernovae dates back to ancient times, with the earliest recorded observation being in 185 AD by Chinese astronomers. However, it wasn't until the 20th century that scientists began to understand the true nature of these cosmic events. In 1934, Walter Baade and Fritz Zwicky at the California Institute of Technology proposed the term supernova and suggested that these explosions were the result of the collapse of massive stars. The first modern supernova to be extensively studied was SN 1987A, which occurred in the Large Magellanic Cloud, a nearby galaxy. This event provided valuable insights into the mechanisms of supernova explosions and their role in the universe. If a supernova were to occur in close proximity to Earth, the consequences would be devastating. The intense radiation and energetic particles released by the explosion would pose a significant threat to life on our planet. The gamma rays and X-rays from the supernova would strip away the ozone layer, which protects Earth from harmful ultraviolet radiation. Without the ozone layer, the surface of the planet would be exposed to lethal levels of UV radiation, leading to widespread destruction of ecosystems and a dramatic increase in skin cancers and other health issues for living organisms. The supernova's shock wave would also have a profound impact on the solar system. The intense burst of energy could disrupt the orbits of planets and other celestial bodies, potentially causing collisions and altering the stability of the solar system. The shock wave would also compress and heat the interstellar medium, potentially triggering the formation of new stars and planetary systems. Thanks for watching. See you in our next video.